So, good afternoon, good evening. Can you guys hear me? Okay, I hope you can hear me. Let me share my screen. So, week 3, we are having one session. Okay, and so one session, and after that, we will go to we will go to what? Now we will have the fest coming up. Just 1 minute, and hmm, sorry, just a minute. Yeah. So we will have one session, and apart from after that, we are having the feast coming up also. So what we will try to do, we will try to discuss uh, the courses which are the things which are there in the in our uh, week 3. So we will discuss that once or twice, and with that we will move towards the next portions. So we will try to solve some of the you know activation questions, some of the practice questions, some of the other whatever else is there, some of the solve with instructor portions and all. So that we will discuss. So we will start. We will discuss cross validation, HDD regressor, and such other topics. How to build baseline models. Okay. So all those things will be discussed, and we'll take a short session. And in case we have doubts or you have doubts, okay, please feel free to ask in the week 4 sessions, which again we will combine with some whatever is remaining in week 3 we can do in week 2, sorry, week 4. Okay, and we can proceed accordingly. So sir has talked about how to build baseline models using dummy regressor. So uh, if you have seen, any before starting week 3, anyone, any thoughts or anything you'd like to say? Anyone has anything to say? Okay, fine. So please learn how. So from the quiz point of view, please learn how to do these things, how to build baseline regression model. Please know what is the syntax. So from sklearn.dummy, you have to import the dummy regressor, and after that you have different strategies. So if you have it makes a prediction as given by the strategy, right? So the strategy can be mean, median, etc. After that you do the fitting with xtrain and xtest. Okay, and after you predict with the dummy regressor, you predict xtest, and you calculate the score based on xtest and y-test, right? So these are the strategies that are possible. One is mean, then there is median, there is quantile, there is constant, all those things are possible. Okay. So how is linear regression model trained? So there is a normal equation and etc. So you have to what are the steps? You have to instantiate an object, and then you have to call the fit method on that object with the training feature matrix and label vector as an argument. Then starts the SGD regressor. Okay, SGD regressor part. So SGD regressor implements a stochastic gradient descent, which is used for large setup. Okay, large data set. So more than 10,000 samples, if it is there, then we use stochastic gradient. It provides a good control of optimization. Okay, and it is easy to implement as well. Okay. So SGD regressor has different loss values and different penalty values. We generally use into penalty, and there is a loss is, I think, generally squared error is the the value which is there. I mean, the what do you say, the template value, okay, which is put there before, if you don't change anything. If you have not changed anything, then it may be like that, but please check in the sklearn manual. Okay, and so all for all of these terms, for all these APIs, uh, please see the sklearn manual if possible, and that would give you more better idea, more clarified idea. Okay, that will be helpful also. Learning rate also we can set, and so many things are there which we can set. So whether we are stopping early, whether we are applying any penalty, whether any loss value is there, whether what is the learning rate. So the learning rate can be constant or adaptive, that we can set accordingly. So whenever you are doing a say you are doing a solve with instructor, you are doing a OPPE, okay, or mostly in OPE exams, online proctored exam, there you will be told what is the learning rate which is set, or which is what is the early stopping rate, what is told. In case it is not told, please use the value which is kept, which is the, what do you say, the template value. I am exactly forgetting the word. You can use what is the given value for the SGD regressor. Okay, so random state, yes, please. So random state we will generally put. So if in case you have to put random state, a particular random state we want you to put, we will tell you that please use that random state equals to 42 or 41 or whatever be the case, so that the values, your answer matches our answer properly. Okay. Now, so we will come to this in how to perform feature scaling, how to shuffle training data. All these questions are important for SGD regressor, because what it may do is, so we you have to look into it, and you have to see that what is exactly happening for each of these questions, right? Because in case you do not see, what may happen is that they may so the questions may come that how to perform feature scaling, and then one option is the correct option, the other option is how to shuffle, the answer for this, how to shuffle training data after each epoch. Okay, so things like that may happen, so please look into the codes properly. Okay, so like first thing which you have to do is, you have to, you have to, let me see whether I can make it in a oh, I'm sorry. uh, I have to know how to present this. Fine. So what you have to do is, you have to import everything. So from sklearn linear model, you import, say, SGD regressor, sklearn pipeline, we import pipeline. So obviously a pipeline is required, because we want to combine, we want to chain up all these uh, all these steps which we are doing. So one step which we are doing is feature scaling, and another step is SGD regressor, right? So again, we have discussed about this topic in notes, that feature scaling is not needed for word frequencies and indicator features, because they have intrinsic scale. We have discussed this in discourse. So again, I mean, just this is my understanding, that as there are word frequencies can be, so word frequencies are always in the same scale, so a feature scaling might not be required, because we are counting just the number of words and all, right? So the scales are not different, hence we are not using the feature scaling. And for indicator features also, they are already in a particular scale, they are already in a in a more, in a standard scale. So therefore, an indicator feature scaling, for an indicator feature also, a scaling may not be required, as they have intrinsic scale. Okay. So similarly, the features extracted using PCA should be also scaled by some constant, such that the etc. Please note how to work with PCA in week 2, how to solve questions, how to implement PCA. That will also be helpful. Okay. Uh, then how to shuffle training data, all those things. Okay, the small things, better if you can know how to do. So see, basically it is very simple. You have to just put shuffle equals to true, then only then you can shuffle the training data after each epoch. Okay, and for the other case, how to do a feature scaling, you just have to put a feature scaling in the in your standard scalar feature scaling, and then you have to put SGD regressor. So in SGD regressor, how do we do feature scaling? We just put a standard scalar or min max scalar or max sub scalar, whatever scaling that we do. Okay. Then for shuffle trading, how to shuffle trading data? You have to put shuffle equals to true. Okay. So those kind of things are there. And apart from that, what is it? What else is there? How to use set learning rate? Okay. So for learning rate, we have to actually just put learning rate equals to constant. We can have learning rate equals to different learning rate are there. Okay. So the default setting is learning rate equals to INV scaling, and they also give you an eta naught equals to 1 e to the power minus 2 and all. These are the default settings. Okay. So please remember the formula of learning rate. So how does learning rate reduce after every iteration? So you remember that eta equals to, so if your value is given, that what is eta naught and what is the power value and all. Huh? So therefore you can calculate the learning rate. Okay. And how to set constant learning rate? Again, this is another thing which we can put. We just have to set that learning rate equals to constant, and if you put that, it will automatically lead to a constant learning rate in SGD regressor. So mostly SGD regressor and so on so forth. So mostly SGD regressor is important. Okay, what is the meaning of in scaling and its use? Okay, so let us see. We can go to scalar. I'm also not sure. Let us see scalar. Now we are talking about SGD regressor, right? Ah. So default is INV scaling or adaptive schedules. So for INV scaling, inverse scaling means, I think for inverse scaling, this is a formula that we use eta equals to eta naught by eta, what some formula is eta equals to eta 0 divided by the power of t and power underscore t. Okay. So the thing is, we have to find out. It's just one value, one type of the learning rate which we use here. Huh? So that is what inverse scaling is. Now, mm, let me see whether something else is written in the user guide. Okay. Hmm. So what are we seeing? We can see that for regression, the default learning rate schedule is inverse scaling, where learning rate, so inverse scaling is the default learning rate schedule, right? So where eta t equals to eta naught divided by t to the power of t. Okay. So now eta naught and power underscore t, they are the hyperparameters chosen by the user via eta naught and power underscore t. Okay. Uh, so nothing more is written, Kanika. Um, do you need more? Then we can try to find in the papers. Okay, or else.
Yeah, actually, yeah, hi sir.
Hi, hi.
Am I audible?
Yeah, you
Yeah.
are audible.
Yeah, actually, I am not understanding that what actually it will do to the learning rate. Like constant, I am getting that the learning rate will be constant. So I am
So
understanding
it
that.
will
But
do a inverse scaling approach. Okay,
so,
regression the
what is
different.
the meaning of inverse scaling here?
Mm, that I mean, so basically, how the so eta naught is a constant, and t to the power of t. Okay, so the learning rate will be, I think, so learning rate should increase as the time actually decreases, right? Because it is t divided by t, 1 by t to the power. If we take eta naught as a constant, then eta t varies with 1 by t to the power of t, right? So,
Yes.
huh. So, can we see? Okay, let me see whether I can get something.
So I can put the power anything like.
Yes, yes, yes. You can put down. Let me. Hmm. This is where SG denotes stochastic gradient descent. Let me see what else is there. Suppose if we see some reference, if it is possible. Hmm. Hmm. And what is learning rate? That is also a good question. That here. Okay, so eta is a step size, sometimes called the learning rate in machine learning. When used to minimize the above function, a standard or batch gradient descent method would perform the following iterations. Omega is equals to omega is equals to omega minus n by eta divided n by n eta by n divided by I from 1 to n gradient of qi. Okay. Mm. With respect to mini batches taken. Mm. So when the learning rate eta decreases, stochastic attenuation glowing. Okay, I'm not sure actually, Kanika. Can I just check and get back to you, Kanika?
Hello. Yeah. Yes. Sure, sir. No problem.
Sir,
Yeah,
in
just
the
let. Uh,
sir,
let
in this case, the learning rate is reducing rate, and t is the epoch. So by default, the p underscore t is given 0.025, and it means 1 by 4. For each cycle, it should be 1 by 4. Then it will be reduced by 1 by 16. And in the third cycle, it will reduced by 1 by 64.
so, what is the power? Can you just repeat what you say?
That is power of t. T is the number of cycles for one iteration. It is, and p is given as by default is 0.25, which is 1 by
Okay,
4.
okay.
And for next iteration it will be 1 by 4 square, t will be 2, so
So
that
you are
will
telling
be
the power of t is equals to 2, and for and the eta
each
naught is equals.
cycle that t will be powered.
No. What I'm telling is this power underscore t. This you are telling is to be 1 minute. This power underscore t. This you are telling to be.
T to the power, that is
This equation we are talking about, right? So you are
exactly,
telling
sir.
eta naught is equals to 1. Eta naught is equals to 1/4.
That will in each iteration we are just reducing the learning rate. We are not giving a constant learning rate.
That is true. That is true. That we, at each iteration we are decreasing the learning rate, and so t you are telling is the time taken to learn. Is it?
No, this is the learning rate, that value we are giving, that we are reducing, because when you are increasing the number of cycles, the error still reducing downwards. So we are not giving a constant learning rate. We are just on every stage, we are just reducing the learning rate. If you go for a constant learning rate, maybe it will overshoot the error points, the minimize point, it will overshoot to the upward direction. That's why we always try to reduce the learning rate so that we can reach the minimum point.
No, so my what I'm trying to say, you are telling that eta is the learning rate, right? Eta is the learning rate, right?
No, this is eta E0 is the default learning rate. If you
Eta
are
naught is
not
the default learning rate, yes.
correct, sir,
And eta is
and we
the,
are just reducing that for each iteration. We are just reducing it.
now t is the default iteration time. So iteration time taken, that is t, right?
Exactly, sir.
And
For
power of t you are telling is 2. 2 or
by
2 or
default is
3.
0.25. It is
No,
already given.
t is 0.25, right? Eta
Nahi,
naught.
p underscore t is 0.25. If I am not wrong,
The power is
Okay,
0.25, sir.
okay. But then how is it changing? So 0.25 and the next iteration what it will be?
0.25 will remain, but the value of t will change.
value of
So
t will be changed.
I think t here means the iteration number, like
Iteration number,
number one.
correct?
Yeah. So like for the first case, we will have a formula like eta naught by 1 to the power 1 to the power 0.25. Let's say our power is 0.25. So for the first iteration, we will have eta by 1 to the power 0.25. For the next one, we will have eta by 2 to the power
2 to the
0.25.
0.25.
So in this way, the learning rate, that is that mu is a symbol, the learning rate itself is reducing over
Mu or
every
eta?
iteration. So that is a mu, that is also a iter, right, sir? I actually don't know the name of the symbol.
Eta.
Okay. Oh, okay. So the symbol eta that reduces over every.
So that is the learning rate you are telling.
Yes, sir.
Yeah.
Yes, sir.
Okay. So
That
you
is
are
the
telling
learning.
t is, and t is the time taken to recycle. Time taken
No,
for.
no, sir. T is I think I mean what I heard in the lecture video that professor
T is the
said
iteration.
T is the
iteration, like
iteration time. Iteration time. Yeah. Yeah.
Iteration.
iteration number, sir.
Iteration number. Correct.
Like first iteration, second iteration, third iteration.
But then why is it constant for constant at 0.25?
Sir, that is power is constant.
That is
Power
default.
of t is constant, but the value of t that changes over every iteration.
So power, so value of t will be 1. So 1 to the power 0.25, 2 to the power 0.25, 3 to the power 0.25, and so on, right?
Yes. Like this, it will
Uh,
carry on. Yeah.
but my question is, why is power of t 0.25? That I
So
have to
we
check.
can set that to anything, like but that will
So power
change.
of t however is
Hmm.
given by power t. Okay. Okay, thank you. So what was, sorry, I mean I forgot. What was the question, Kanika?
Yeah, sir. Okay, I got their point that it is decreasing with respect to time, right? Or with
Huh.
respect to iterations that are performing. But here, whatever article you have opened,
Huh.
they are initializing that where t is a time step. So is it same, like time step
T
is
is the
same to the
iteration.
number
Yes.
of iterations?
No. We are not. They are not talking about number of iteration. I think they are talking about the iteration itself. So iteration means that iteration itself is taking some time, na? So first iteration, as far as I understood, if they are correct, I have to check. If they are correct, it is 1 to the power 0.25, then 2 to the power 0.25. So first iteration 1 to the power 0.25. Then second iteration is 2 to the power 0.25. So again it reduced a little. Then 3 to the power 0.25, again it reduced a little more. Okay, and so on. So that what happens is when there is a learning rate, so as we are increasing the our iteration, as we are revising the learned system more and more, we are reducing our time for revision, or our time for learning. Okay, that is what I think is explained here.
Okay, sir.
Do,
And then what it means by adaptive, right?
so adaptive, I think adaptive will, I mean, basically what it means is that it will change with time, and with change with it will change with whatever code we put, and accordingly it will it will
It
so
will
for an
moderate
adapt, yeah,
itself.
yeah, it will be
Right.
moderated. So for an adaptive decreasing learning rate, so we can use learning rate equals to adaptive to specify the starting learning. So we can specify the what is our initial learning rate, and whenever the stopping criterion is reached, then the learning rate is divided when the algorithm does not stop. So we can adapt, or we can set our particular starting or stopping time, starting or learning rate. We can change whenever that condition appears. So whenever the stopping, what is the stopping criteria, that we can set in the adaptive case. Okay.
Okay, sir. Thank you so much.
Yeah. um yeah. So okay, I will also check what is the okay. Yeah, what I told, and what Abhishek and others told. Yeah, we'll check also. Thank you. Um, yeah, so I think so. Those small things, please you note down. I mean, whenever so these kind of things may come. So, what is the output of this one particular code? What exactly is this code doing? So, like how to set epochs here, right? So we can say, ask that we can give you this code snippet, and they may ask that what is the purpose of this code snippet? Is it is it setting epochs in the SGD regressor? Is it doing a shuffle split? Anything, and two other options. Okay, so you can see that it is just checking the maximum iteration number, and so we are setting the desired epochs. So those are some small 2 marks questions which can come. So SGD, again, SGD converges after observing 10 to the power 6 training examples, and so therefore a reasonable first case will be to to set for an in sample, the values are maximum iteration number equals to ceiling value of 10 to the power 6 by n. Okay, so
Sir,
yeah.
sir, here, sir, I have a question, sir. So, max iter, what is this determining? Is it determining epochs? Like how many epochs will?
Yes.
So,
Desired number of epochs.
like I have a data set, so it
Mhm.
will go over that data set for 100 times.
Full data set over 100 times.
Full
It
data
will do
set
a
over
full
100.
pass over the I mean your training data set 100 times.
Yes. So, I mean, let's say I have 200 rows, so it will go over these 200 rows for 100 times.
Yes.
Okay. Okay, sir.
Okay. And similarly, as starting criteria, and how many times we can iterate, there is a stopping criteria as well. Okay. So we can put when the training loss does not improve for this many number of epochs, it does not change. Then we can set the we can stop the value. We can stop running the we can stop running the SGD regressor. Else, if there is we have put one maximum iteration, like 1000 iteration or 100 iteration we have put. So after 100 iteration, it will automatically stop. Okay. So like from here, in this case, it will stop after 500 passes over the full training data. Then there are some other things which we can do. We can set a validation fraction, which will record from the training set as the validation set, and so on. We can do. Um, and loss is equals to squared error. That also we have seen that you can set different loss functions. You can set a loss equals to squared error, and uh, other things also are there. I think yeah, okay, so only square error loss is there. So square error loss, Huber loss, etc., those are there. Huh? Now square error is studied in this course, so we have set loss equals to square error and all. Now average SGD is there. Average SGD that updates the weight factor to average of weight. So it will update the weight factor to the average of the previous updates. And what it does is that we have average equals to true. You just set and so on. It will take care of the
Sir,
averaging. Yeah. Yes. Yes, Abhishek. Abhishek.
Sir,
Yeah.
sir, I have a doubt in a previous slide. What was a tall, TOL, tall?
That is not tall. There is TOI.
So,
1 minute. Where is it?
the previous slide again.
Ah,
Yes, there. Yeah.
TOI. That is 1 minute.
No, sir, that is TO thing.
Okay. Let me check. Oh, sorry.
Tolerance, sir.
If that is tolerance, right? Sorry. I confused with something else. Okay. Just yeah, you can see it here also. 1 minute. Let me go through. That is the. Thank you, sir, who told how to set stopping criteria in HTTP. Yeah, this here only, the. Yeah. Yeah, see, this is tolerance. So this is the stopping criteria. If it is not none, then the training will stop when the loss is greater than the best value of loss minus the tolerance level. Huh? And convergence is checked against the training loss or the validation loss, depending upon the stopping criteria. Okay.
Yes.
But some other place also I saw the tolerance level. Okay. Yeah. Uh,
Sir, sir,
sure, sir. Tell.
so here it is saying that it will average the weights from the previous updates. So by these previous updates, does it mean that it is updating over the previous epoch or updating over the previous iteration?
I 1 minute. So it was here, right? 1 minute. Where I was seeing the
Sir,
average
average,
update.
how to average SGD? That slide.
1 minute. Yeah, let me go there. How to average SGT? Yes. Now your question is, sir.
Sir, here it says like it will
Average equals to true.
average equals to average the weights from previous updates. So my question is like I mean, how are these updates? How are they considering these updates? Is it over every iteration or is it over every epoch? Like
But
in
in
one
one
epoch, there can
iteration,
be
huh?
one epoch, there can be many iterations, right? Like for SGD, I will have n number of iterations.
Um, 1 minute. So, okay. But one epoch is one full pass, one full iteration over the training data, right?
Yes, sir. So,
Huh.
so in SGDs, that is stochastic gradient descent,
Mm-hmm.
we take the samples, we take each samples, and we then iterate over the next one.
Okay. Sure.
We take each sample. So, if I have a feature matrix of 200 rows, then I will have 200 iterations, and I will do this 200 iteration for 100 times. That is the number of epochs. So my question is like that the update that we are doing on the weight vector, is that based on that iteration or is that based on this epoch?
I think that is based on the iteration only. Okay. I'll just
Okay,
check, but I think it is based on the iteration only.
I think it will do the full test first, then take the average of all the weights across all the epochs. That will store as the coefficient of the weight vector.
Why are you doing that?
When you are using average equal to true, only average equal to true, it will the coefficient of the weight vectors, that is the average of all the updates. And when you are averaging on some integer value, then it will looks for the number of samples.
Okay.
If you are setting, for example, average equal to 10 and we have only 5 samples, then it will do nothing. Then the average is by default, it is a false like that. When the number of samples more than 10, then it will average it.
Okay, so in that case, you are telling that it is based upon the full epoch. Full epoch, it will run over.
Exactly, sir.
Yeah. That is true. That is true. I think that may be correct. That may be
so
correct.
the weight vector will be passed from one epoch to another.
Hmm.
Okay,
One epoch.
No,
Mm.
the default is SCD. It will goes on number of people. That is maximum iteration. You are giving 500 without any on other constraint. So the final output, the weight vector, that will be the average of all the updates.
Abhishek, can you just put this question in discourse? I'll just see it and respond back to you.
Yes, sir, I will. Yes, sir.
Can you just put, let me give some time to check, okay? I'll
Okay,
just
sir.
let me see whether I can answer it properly. Okay,
Okay, sir. Okay.
I'll also look into it. Yeah. Anyway, thanks, Mr. Shobit. Thank you. That was a nice answer, actually. Then let us go towards the other whatever else is there. So we have learned SGD regressor, and so let me see some other things. What else are there? We have learned cross validation, right? Can you just tell me whether sir has taught all these things? Then we can go through them once. And so you have learned explained variance code, right? Kanika, Mr. Shabit, Mr. Abhishek, anyone? Have you learned explained variance code?
Explain variance.
Sorry, sir, I haven't been through videos of week 3.
Okay, please, yeah, please go through them. Okay, please go. Explain variance code is important. I'll tell you these few things are important here. Explain variance code. What is the formula? I'll note in the chat window. Explain variance code formula and code snippet. One thing. Then there is SGD regressor, and many people have already read SGD regressor, so that is important. That is okay. SGD regressor. Uh, how to basic criteria. I would say if you can understand the first page, this is not a very technical thing to say, or um, course specific thing to say, but I would say that this is a good suggestion. First page of the scalar manual, if you understand, that is more than enough. Just understand. I'm not telling you have to memorize and all. Okay, so like this page, this is the
So,
skill. Yeah, sorry.
was this discussed in the lecture, sir? The slide that you showed us just now, the collab.
No, no, yeah, I am discussing. I was discussing explain variance code.
Yes, sir. Was this discussed? I mean, I don't remember. It says week 2, but
No,
in
no, that
week.
is okay. Week 3, I am talking about. That is okay. I mean, that is wrong.
Okay, okay. So week 3. Okay, okay. No, no, sir. I have not. If
That's
it is
okay. That's
week.
okay. So I'm mentioning in the chat window what are the things you should read. Okay, just go through these things. Scalar manual, first page. Okay, the SGD regressor, basic criteria and coding. These are the things you should know. Okay, and let us see what else. Let me explain what is explain variance code. Explain variance code is basically another statistical ratio. So if you have a target output y cap, and you have a y cap is your estimated output, and your exact data value is y, and var is a variance. Okay, then what we can do, the square of the standard deviation, then the square of the which is explained variance, can be estimated as 1 minus variance of y minus y cap divided by variance of y. Okay, so suppose if you do a write a code. Okay, 1 minute. Okay, these are practice questions. 1 minute. Huh? Okay, by that time let us calculate here. So from sklearn.metrics, we have to import explained variance code, and if you do a prediction of let me write it somewhere, otherwise it is difficult to. Okay, then you have to, you can see that it will give you some value of 0.9571, etc., etc. Okay, so explain variance code. This is the formula. Please remember the formula, that you know the variance value of the variance, right? Value from the stats course and wherever. So remember that explain variance code is, or EVS, that is 1 minus variance of the our this value, the calculate the correct value, the data exact value, correct data point target output, minus our estimated target value, divided by the variance of the variance of our estimated target. Okay, so that you have, that you can see, and this is a, so what is the maximum minimum value or maximum value that can happen? Suppose we give a completely another topic. If we give, say, minus 7.1, 100.5, 2 should not be there, so we want a complete reverse thing, minus 2. This is, we say this is minus 8. I'm just checking, okay, what can happen. So see, the explained variance code can be negative as well. Okay, so it can be minus 0.08 or so. So basically, as we are seeing here, that the best possible score is 1.0, and the negative score can be less than 0 as well. Okay. Yeah, yeah.
Sir, can you just briefly tell like how the variance of a matrix is calculated?
Variance of a matrix.
Yes,
Okay.
yes, sir. Like
Then
here,
again, that I
why?
have to check. Then no, y true is one value, right? Y true is, I mean, there are different predicted values and corresponding true values. Isn't it? So for 2.5, our corresponding true value is 3. For 0.0, our corresponding true value is whatever be the case. Okay. So you have to actually calculate y minus y, one column you have to make, then a variance of that, and we have to calculate the variance of the y predicted. Okay.
Yes, sir. That I
Can you just
understand.
check whether
I'm just saying like how is the variance of a matrix is calculated? Like I know how to calculate if I have a data, I know how to do that in statistics, but like in matrix, I think I
I,
forgot.
I think what we do not need here the variance of a matrix. What we need here is see the all the separate data points. These are our predicted results, right? Y prediction. So my point is, can we calculate the variance of 2.5? Suppose here from 2.5, 0, 2 and 8. These four numbers.
Sir, can we calculate? Can you repeat that again?
Yeah, I mean, we are taking four numbers: 2.5, 0, 2 and 8.
Yes, sir.
Is it possible to calculate the variance of that?
Yeah, yeah, I mean, if it is not in a matrix form, then we can do that. Like we have to
Huh.
find the mean, we have to check like the distance from the mean and do the square, like the basic formula.
Hmm. So the similar way, one, if we do that, so that should give us variance of y, right?
That yes, yes, yes. If it is not a matrix, like if it is a matrix, then I don't know what will happen. But if it
I
is not a matrix, let's say y has these four values 2.5,
hmm.
0, 2, and 8, then we can first find the mean, then we can
Can you
find the.
check? I think that is the only thing. That is the thing which will happen only. This will not lead to a variance of a matrix.
So in that case, if
Uh-huh.
it is a multivariable, this multi-level matrix, that is, it has more than two features.
Hmm.
It has more than two columns, more than one columns. Then we cannot find the variance, right?
Uh, No, I mean, in that case, we can find the variance. No, in that case, obviously, that there should be a way to calculate the matrix, calculate the variance of the matrix, right? I am talking about this particular example only.
Yes, sir. Like the what you said, I and like for this example, the process is somewhat similar only.
Hmm, hmm,
Like the normal process.
hmm,
But I am saying like matrix. This is a matrix of only one column,
one
right?
dimensional matrix.
One dimensional matrix.
Huh,
So
huh,
if I have a multi-dimensional matrix, let's say
hmm.
2 cross 3, 3 cross 4, like this. So
In that case, I'm not sure. I'm not sure what is the way to calculate the variance of a matrix. I have to check, but yeah, I mean, we won't give you a thing like that. But what we can do is, yeah, I mean, we will just put explain variance code, and we can, yeah, we can see what is the formula for the explain variance code, maybe. Okay, for the matrix variance of the matrix in that case. Okay,
okay.
let me check. Let me check. Let us check what is said in the explain variance code. Is anything is there? Regression score function. Hmm. See, you can calculate actually. I mean, this is the kind of thing you are asking, right? 3 by 2.
Yes, sir. Yes, sir.
How to calculate? There are so many things there.
So can I share the link?
Yeah, please share.
Okay.
What link you are sharing?
Uh, it is a code how to calculate,
Okay, sure.
but in C++.
Okay, sure. Please send. Geeks for geeks. Huh? Given a matrix of size n cross n, you have to calculate the variance and standard deviation. Okay. Mean should be calculated by adding the sum of each elements. After calculating mean, it should be subtracted from each elements. Acha, then square each term and find out the variance by dividing sum with the total number of elements. Okay. Mean should be calculated by adding the sum of each elements of the matrix. So, Abhishek, I think that should help us, isn't it? Uh, the mean should be calculated by adding the sum of each elements, and after calculating mean, the mean should be subtracted. So basically, for each element, we are calculating the variance. That is the only thing which is happening. Okay, it should be subtracted from each element of the matrix for
So,
calculating mean.
so below there is a code. It will be more clear.
But code
Down,
is more than the code. Yeah, Python code. Okay, more than code. I think this one, just let me go through this part. It should be subtracted from each element of the matrix. Then we square each term and we find out the variance by dividing the sum. Sum was what, Vishan? After calculating, it should be subtracted from each element and square each term. Okay. Find out the variance by dividing the sum with the total number of elements. Okay, fine. So what are you doing? Let us see Python program to find mean and variance of matrix. Import math. We are defining a function and calculating a sum equals to 0, then running a loop for I in range, for j in range, sum plus equals to matrix. Okay, fine. So we are calculating the sum. Acha. Returning mean and function for calculating variance again. Fine. For I in range and j in range, subtract mean from the elements. Okay. Then square each term, take sum.
This is
So
just a normal variance calculation.
It is just a normal variance calculation for each of the element. That is
for
what
each
it
of the
says.
elements, so that
Each
is
of
what
the
I am.
elements in the matrix.
So they are calculating the mean over all the elements.
Yes, yes, yes. All the see basically
Un-
I think yeah. Tell me.
Understood, sir.
Yeah, so basically I think this part is more easy to understand. I don't know.
Sir, in this case, if it's the input, then first we will calculate the sum 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 divided by 9. It is the mean value. Then
Obviously.
we
Yeah.
have to 1 minus mean square plus 2 minus mean square plus 3 minus mean square. We have to add all these terms divided by the total number of terms.
No, the square each term and then we have to find the variance.
Exactly.
Right?
1 minus mean square
Huh.
plus 2 minus mean whole square plus 3 minus mean whole square,
Huh.
9 minus mean whole square. So total sum divided by number of elements is 9.
I
That
think so.
will give us the
Can
standard.
anyone check whether this is giving the this value 6.66? Then you can verify, or else we can see where is the code we can do. Hmm, Let us see. Okay, but here we need two. Okay. So no, here it may not work. Because we need both the true matrix as the and the predicted matrix, right? So here we need two sets of data values. Okay. But here, then how do we do the variance calculation?
Yeah, it is giving the same value, sir.
That 1, 2, 3, 4, 5, 6 is it?
6.6. Yeah.
6.6.
That's 6.67.
Okay. Okay, that's thanks. Thanks you, ma'am. That is great then. But my question is where okay, I'll look into this. I mean, how can we calculate? How can we show the calculation of this set of data?
Sir, we can convert our data to an numpy array and numpy dot where is directly give the variance.
No, theory. I mean, I want to do this by hand. That's what I'm
Sir,
asking.
which part, sir?
This y true and y pred. Now this
Yes.
part I want to show you. How can we do that variance calculation? What Kanika ma'am
In the
just told.
same way, I think like first we have to subtract y true minus y prediction, then calculate the variance.
Hmm. So
After
matrix
subtract,
subtraction and matrix then squaring
then
each
find the
term
variance.
and
So
all.
after
Yeah.
subtraction, we will have the same shape,
Yeah.
same
Okay.
dimension of the matrix.
Of course. Of course.
Then we will find the variance like you explained.
Okay. Yeah. The normal way. Normal way.
Normal
Yeah.
way. Yes, sir.
Okay. Okay. So anyway, thank you, everyone. So anyway, we won't give one matrix to you. We will just give you small values so that you can calculate it with the formula in your quiz and all. OPP may be difficult, so there obviously you can calculate. Uh, what happens here? We have to import. Okay, so this is an array it's given. Anyway, what else is there? Where we explain variance score. Yeah, sorry, please tell me.
Sir, actually I joined late, so in the first slide, I have one question like when we are using default regression, so there we are using a strategy called mean. So
Huh.
is this I mean by mean? So are we calculating the mean of the normal distribution or something like that?
Strategy called mean, right? 1 minute, 1 minute. Where are you using? One. SGD regressor, right?
or dummy regressor, sir.
Dummy regressor. Dummy
Yes.
regressor is 1 minute. Huh? 1 minute, sir. Mm, there are so many things. Strategy equals to mean. Some statistical property of the training set or user specified value. This is dummy regressor. Okay, dummy regressor strategy equals to mean. Let us see what is given in the dummy regressor. So your question was what was the question now, Abhishek?
Sir, here the mean we are using. So is it a
Haha.
mean for like normal distribution?
Mean of the training set predicts mean of the training set. Okay,
Mean of
does
the
the
training set.
mean of the training set? Huh? It always predicts the mean of the training set. So strategy, that is the strategy to use to generate predictions. Mean means it will generate a mean of the training set. Median will predict the median of the training set. Quantile predicts a particular quantile of the training set, and constant predicts a constant value provided by user.
So what does it mean, sir? So actually, this mean of the training set.
Hmm.
What does it actually mean? Like, what is
No,
mean?
dummy regressor does what? Dummy regressor actually makes a baseline, isn't it? So dummy regressor is a simple baseline compare with other real regressors. So used for a real life problem. Okay. So it will just say, okay, the mean of the training set is this, therefore the mean of the testing set also can be this. Okay. This much it can say. But again, this regression is just a one fast line of statement. Oh, so we checked the training set data and the mean is this one. So we can expect that the mean of the testing data set also can be something like this. That is our baseline. From there, we start comparing and we start calculating. Okay. So again, that is why it is telling that do not use it for real life problems.
So like when I don't know exactly for MLP or MLT,
Sure,
whenever
sure.
we used to do a description, like we used to find the statistics of the whole data, mean, median, quantile, like
Sure. Hmm.
and
Hmm.
this. And based on that, we used to assume that which distribution it might fit or which strategy we should take. So this dummy regressor is doing that, right? Like it is finding all these details for us, this mean, median, quantile.
Yes.
uh,
Yes. It's a yes. It's a no, not finding the exact mean of the distribution. It's just based on the training set, it is predicting the mean can be like this.
okay.
The a starting point can be like this. Suppose I have 100 pens to count, okay, or 100 pens to sell. I can sell with maybe 10 days per 10 pens per day. Okay, that's just a baseline I'm taking.
Okay, okay, okay.
Okay, or if you take a mean, then 50 pens per month. I have to sell 100 pens in 2 months. I can start with 50 pens per month, a target.
Okay, so let's say I have a
Okay,
requirement
so
for
that is
pen.
an average.
Yeah, yeah. So I say I have a requirement for pen for over a year is 600. So it will say so the mean might be 50, like this, right?
What do you mean the mean might be 50?
So it is predicting the mean to be 50, right?
Huh, I mean,
For
yeah, I
each
mean,
month.
whatever be the case, whatever. Huh, so 600 by 12 you are telling, is it?
Yes, yes.
Obviously. So you can tell average 50 pence if you sell per month. That is
Uh,
the baseline
baseline,
prediction. Okay, so if
baseline.
we if we if we sell 600 per year, then we can say that maybe 50 he has sold per month. Okay.
In reality, it might not be the case. He might have
In
sold
reality, it may
30.
be 30 or 40. yes, so that is why it is telling do not use it for real problems. Okay.
Understood, sir. Understood.
Yeah, okay, yeah. I think so. Is anyone would like to contribute anything, Mr. Shobit, or anyone? Aditya would like to contribute anything? Please go ahead. Okay. Let us
No,
see.
sir.
Yeah, yeah. Okay, sure, sir. Thank you. So some of these error values are there. So we have max error. Max error function is also similar, like, and it is easy to calculate. So we have maximum residual error. It captures the worst case error between the prediction and the true value. So what is the maximum that can maximum error that can happen between the prediction and the true value? So yi is the predicted value of the ith sample, and y cap I is the predicted value, and the y to I is the true value. Then you can define the maximum error as the difference, right? The difference between prediction and the maximum difference between prediction and the output, and the estimated output and the correct output which we got. Again, we can do, we can, so so what is the difference between 3 and 9? That is 6. 2 and 2, 0. 7 and 7. In this code, you can see 2 and 2, 0. 7 and 7, 0. 1 and 1 is also, if you subtract, that is 0. So what is the maximum error we are getting? So 9 minus 3, that is 6. Okay. So now my question is, so the question comes, suppose let us run this code. So we have 3 here. So does this give the modulus of the value, or just will it give minus 6? So this gives actually the modulus, right? So if we put minus 9, what is the difference between minus 9 and minus 3? Then also it is 6 unit. So this gives a modulus of the maximum error, huh? So what is the maximum magnitude difference between a true value and the predicted value? Sorry, I'm so. And similarly, yeah, someone is stealing something.
That we are talking about that dummy feature strategy mean.
Okay.
If that's not clear, can I say something?
Sure, please go ahead. I think Abhishek was asking the question. Abhishek, yeah.
In that case, the strategy is mean. So what exactly, when we have a data, then we have X train and Y train. We have just splitting that data. So the strategy for value of X, the output is predicted based on the labels that Y value mean. For example, Y is 2, 3, 5, and 10. Then in that case, the mean will be something coming to be 5. So for every value of X, the prediction will comes out to be 5. Like in this case, X train and Y train. X train has some data and Y train has some data. That value is, suppose X train is 1, 2, 3, 4, and Y is 2, 3, 5, and 10. Sir, it is audible.
Yes,
Hmm.
yes, yes.
When we use the strategy as mean, so it will take the mean of the Y train. So 2, 3, and 5, 10, that mean coming to be 5. When you start to predict the X test, whatever value is there for 2 or 3 or 5, the output always comes as the constant value, that is the mean value.
Understood, sir. Understood.
Okay.
Is clear?
Okay.
Yes, yes.
Thank you, Mr. Shobit. So there are some other, other error values also. We have known, we do know some square error. Okay, these are the formulas we are learning from previous year, right? In maths 1 and maths 2 and all. So we have mean absolute error, okay, which is 1 by n summation mod predicted minus calculated, sorry, true value minus predicted value. Then we have mean absolute, that is mean absolute error. Then we have mean square error. Okay, mean square error is MSE, which is equals to 1 by n. Where there we are just doing a square, so therefore a modulus is not required, right? So yi minus y cap I, the whole square of that. And then obviously we have RMAC, that is root mean square error. So that is just the root of the MAC. Okay. If you put a root, and that is that. Um, this is important. The R square again. R square represents the correlation coefficient of determination. Okay. And
Sir, here I have a question.
so R square's base. Yes, please tell me.
Square, we are calculating this. I mean, in the slide it was given 1 minus u by v.
1 minus u by v.
So you,
Okay.
it's same formula, sir. I
Okay.
am
Okay.
just
Fine.
same formula.
Fine. Fine.
So
Now.
now, sir, here it is also saying like a constant model that always predicts the exact value of y would score 0.
A constant model that always predicts the expected value of y disregarding the input features
Yeah.
would get a
So,
R square value of 0.
so if you write the numerator here in the formula yi minus y cap I square, if you write that, you can write that in matrix form. If you write that, that will be y minus y cap mean transpose into y minus y cap mean.
Okay. Okay.
So, this is for the denominator, and
Okay.
for the numerator we can write xw minus y transpose by xw minus y. So actually my question is like, what is happening in constant model so that this is cancelling out, these two parameters are becoming equal? What is exactly happening?
If it is a linear equations, all the data points lies on the same line. There is no deviation, so that the predicted and the actual is same. So in that case, u equal to your v. So u by v equal to 1, 1 minus 1 equal to 0. So all the data points lies on the line only. There is no deviation.
So that is a, I mean, that is a typical case of overfitting, right?
Not overfitting, I would say. Uh, Mr. Shobit, can you draw what you are showing, or can you
Sir,
share what you?
actually, in this constant line, when you draw a
Huh.
line and when you draw the scattered plots of x and y lines, so all the points, data points, lies on the line only. So
Okay.
in that
Okay.
case, that the error is 0.
So if you're so you are telling a constant model that always predicts the expected value of y, that predicts the expected value of y.
And actual and predicted both are same. There is no deviation. So that
Then
is
it will
called
be
as a
0.
constant. Exactly, sir.
Because 1 minus the
1 equal to
remaining part
0.
will be 1. Is it? The remaining part should be this fraction part should be 1, right? Then only it will become 0.
Yes,
Also
yes, sir.
same. It will u equal to v. Both upper and lower part both are same. They are identical.
So that's why I mean so that is why the value will be 1, right?
Yeah, that value
Yeah.
will be 1. So 1 minus 1 equal to 0. So in
Yeah,
that case, r
0.
square will be 0.
Yeah.
But
So if you okay, also please go ahead, Abhishek.
yeah, so like I calculated, I did a deduction. So I was getting like this y cap, that is the predicted matrix, will be equal to the mean y cap mean.
y cap
So
will be equals to y cap mean.
yes, yes, sir.
You want me to write it somewhere? One minute.
Sir, tell me something like, can we expand this yi minus y cap I in normal way, like we use like we do in algebra, like a minus b whole square? Can we expand that?
Yes, I think so. And after that, we can do a sum. I mean, there is summation. So yi square minus 2yi into y cap I. That's y cap I square. And over each of them, there will be summation, right?
Yes, yes, yes,
Huh. So so what they are telling is it is always this numerator and denominator part is becoming equal. Okay. So if numerator and denominator is getting equal, then therefore, so basically on the top also there is y bar I only. So y bar I is if you take y bar to be mean, so yi minus y bar I. So our mean is one line, huh? And if the predicted value is always the mean value, suppose, okay, in that case, so if y cap I is always y bar I, then what is happening? Then we have one line which is mean, and so the data points from that, so the our predicted value is, if it is always mean, then what is happening is that the prediction, the difference between the prediction and the actual output is always same, right?
yes, yes, yes,
I mean, it is not always same. I would not say it is always same. I would say that there is a constant value of the prediction, right? So it always predicts the expected value of I or of y, or the mean of y. In that case, what is happening is that, I mean, again, I'm coming back to Mr. Shobit's thought only, that it is becoming, the numerator is becoming same as denominator, and in that case the r square will become the 1 minus 1.
yes, yes, sir. I
Okay.
understood. Uh,
Okay.
so here the
Yeah.
one another last thing, sir, like this
Sure,
y
sure.
mean, y cap mean,
Mm-hmm.
this y bar here, it is given in the form of y bar. Yes, sir, this one. So in the slide it is given y cap mean. So
Huh.
y cap mean, is that a scalar value or is it a metric?
uh, that would depend, I think, that would
It
depend.
depends upon your
Yeah,
label. It
yeah.
may be single, it may be matrix.
Yeah, let's say it is a, I mean, I have more than one rows, more than one rows. So
Huh.
then it will become a matrix, right?
Huh.
Then it will become a matrix. But
Huh.
what is the, I mean, formula, or how are we getting that matrix? That is a question, right?
Then again we are going back to the previous one, right? That how are we calculating the variance of a matrix?
Yes,
So
yes, that is what I thought. That is what I thought. But there we are doing a y minus y mean, y minus y cap mean. So if y cap mean, so here we saw that in while calculating the variance, we saw that the mean, that is a scalar value, right?
hmm,
Whatever the
hmm.
dimension of the matrix, the mean is a scalar value. So if y cap mean also is also a scalar value, then how can we subtract it from a
Matrix.
matrix? Yes. If you can please open the
Hmm.
MLP slides, sir, it would be really helpful.
This presentation only.
Yes, 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 yes. Letter, I mean,
1 minute. This is here linear regression.
yes, this one, yes.
Now your question is
So
u is
sir,
equals to this and v is equal. Okay.
yeah. So u is understandable, that there is no problem. But v, you see here it is given y minus y cap mean.
Transpose.
Mean and transpose of that. So transpose that I understand, but this mean part, this y cap mean. So y is a matrix that we know.
And y cap mean is may not be a square, may not be a scalar.
It's not y
Mean,
hat, it is y mean. It is wrongly represented here. It is y mean. Y true, or we call that the true value, and the true of that mean. Y
so
mean.
by mean you are referring to a scalar value, right?
Exactly.
By mean you are referring to a scalar value, right?
So how are you subtracting a mean a scalar value
And
from a matrix?
yeah, that will possible. Matrix, when you subtract it from a scalar value, it will automatically change the dimension of that mean value to multiple dimensions. That is the rule is over there. If it is a normal scalar matrix is there and you are subtracting from a constant value, that will automatically change the dimension. That is some rule name I just forget. We can do that.
So you are saying like I have a matrix, let's say 1 2 3 4.
You
And
can subtract a constant real value. It will automatically convert that into a matrix and then plain subtraction.
So constant real value that will form
That
a
will convert it to a matrix.
okay.
In I think it's in week 1 itself.
So is this rule for is this rule of a mathematics or is this rule for this computer?
No, it will automatically project it, that to a matrix.
What is
Okay.
the rule, sir? Sorry, what is the rule? Can you please repeat?
It will
Can you please repeat what you're
automatically
telling?
convert that numerical linear value to a matrix. That is some rule is that when
Yeah,
we
the
do
numerical value. Okay.
like we do matrix multiplication. That's some constant rule. That exact naming I just forget.
Okay. Okay. Fine.
That will check
Please
it.
tell.
If it is not that, then it will convert that to an same scalar matrix. Then it will do the normal subtraction.
Matrix operation.
Exactly, sir.
So Mr. Shobit is telling if it is a scalar, then it will convert the scalar to a matrix, and then it will pursue with the matrix subtraction.
Then it is understood.
Yeah,
Then it's
that seems like a logical.
So when we multiply the scalar value to the unitary matrix I, it will automatically
Yeah,
convert
obviously it
into
will.
that dimension.
yeah, that I understand. That I understand. But in case like I what you just told, that I understand. But in case my scalar this label vector y is a level vector, no? So if my level vector is of like 3 cross 1, let's say my level vector is of dimension 3 cross 1. So I cannot find any I for that, right? I is always a square. Identity matrix will always be a square matrix, right, sir?
Okay, so you're telling if it is a, I mean the dimensions are not equal. If it is a not a
Dimensions,
square matrix.
exactly. Dimensions are not equal. They are the level matrix is not a square matrix, which is which is quite practical, which is what we see most of the cases. So in that case, we cannot get an I.
Then how, in that case, how do we?
So Sabit, Mr. Sabit told that it is we project the scalar on the vector, like the level vector, then we subtract it. Okay, that makes sense.
Okay. Cool. Okay, anyway, we will not. Uh, 1 minute. This is art plus. Okay, sorry. This is the GitHub of Skillr. So okay, okay, I'll look into it. Another thing which we have to see is okay, density. What else is there in the slide? Let us see. Shuffle split is there, and the train test split. So obviously, you know, I mean, train test split. We are not going. I mean, for every case we are doing, we will do train test split only. So for IDs or California housing, whatever we do later, the first few lines will be train test split, and what is the ratio of the train test split that we are doing? R square we discussed now, and okay, this we have already seen before. This also we have seen mean squared log error, percentage. So many errors can be there. What else is there? So okay, so we have something called cross validation. Let me see whether we have another. Yes, cross validation. Mm, yes. So cross validation is okay. Let me. So there are different types of cross validation strategy which we will see in our lecture. So, okay. So we partition the train in k-fold partitions, train with k minus one, and then validate the model performance. Okay. So k-fold, if you have a k-fold cross validation, then we divide all the samples in some groups called folds. Okay, and then we learn the function using k minus 1 fold. And so every time we do we fold this, the fold which is left out, the group which is left out, that is the that is our testing data set. Okay, so if you see in the slides, so sklearn implements this kind of cross validation iteration. So cross validation is basically a evaluation strategy. We have different types of cross validation strategies. So one is a k-fold, then there is repeated k-fold, leave one out, and shuffle split. All of these are our different cross validation strategies. So if you see what is cross validation, you will see that it is basically 1 minute. Yes. So it's a technique for estimating what is the performance. So basically what we do here is we try to we try to check what is the performance of the linear regression model. Okay. So what we have here is it's a cross value, it's a model of testing. Okay. Model validation testing for assessing how the results will generalize to an independent data set. Okay. So it uses different portions of the data to test, and it trains a model on different iterations. So suppose we have six, we classify into six parts, and we train on 5 parts, and then it runs on the it runs the test. It takes the testing data. The remaining part it takes as a testing data set. So it is used mainly in settings where the goal is prediction and how accurately we can predict it. So it is given a data set of known data in which a training test is run, and a data set of unknown data, or the testing data set. Now what cross validation does is, now cross validation let me see whether it is there. So cross validation takes each time one set of training data. So suppose here if you see, this is a diagram of k-fold cross validation. uh, 1 minute. So suppose these are our these are the our data set. These balls are red, green. These balls are our data set. So what we do, we take one portion as our test data, and then we train on the remaining data set, whichever is there. Then in the second iteration, what we do, we have we take the next set We actually classify into four sets. Okay, so fourfold cross validation, right? So each case, with each time, we each iteration, we take three data set, three fold of the data set as the training data, and the remaining one part we take as a test data. Each term, each iteration, that is only happening. You see, so every time we take some portion as the a large portion as the training data, and remaining part we keep as the testing data. Up to like that, we can go up to kth iteration, and so that when all of the data are combined or completed, okay, all of the data are tested, then that is when we can see how we can estimate how properly the model has accurately how properly or accurately the model has estimated the data. Okay, so that is called k-fold cross validation.
Sir,
Yes, sorry, please tell me.
sir, if I am not wrong, we first split the data into training and test data. In case of K-fold, we split the training data into K different sections, and K minus 1 is used for training and 1 for validation.
Yes, one for testing purpose.
1 for validation. Testing
Acha, one
data
for
is
validation purpose.
testing data is unseen data.
Testing data is
Unseen data.
obviously.
But
Yeah, okay.
your
Yeah.
figure shows that
This uh actually, if you think the full thing as a, yeah.
the basic concept of K-fold is we split the training data into K different parts, and K minus 1 is for on each iteration, K minus 1 is used for training, and one set is for validation. Similarly, go around this, we trained our model, then that model predicts the result on test data.
So you yeah, obviously. So we can see that. Obviously. So we can say as a that the remaining part, which is shown as the test data here, that is actually, yes, obviously that is possible. So that we take as a validation part, and obviously again then we can see how, I mean, see, if you are taking that as the complete data set as the validation data set. So what is validation data set? Na? That also we are just trying out that in case that was the test data, how it would behave, right? So we are just telling that if this was the
But
this
in this
whatever is
figure, the test data is shown to the trend model.
hmm,
Because
hmm.
each time we are just because what I understood till date, test data is unscreened, which is not any time used in the training the model.
Yes, I agree. That is the case. That is true. That is very true. Now what I'm telling is, see, yes, I agree, this labeling is wrong. So what I'm telling is, see, this data, what is validation data, right? Validation means we will see that we are taking that in case that was the test data, right? Then how the algorithm would perform, right? So from that aspect, I am telling that if in case this was the validation data, or as you told, this is the validation data. In case this was the testing set, then how it would behave. So one part, as Mr. Shobit told, that is true. As one part we keep for validation, and the remaining full part we are keeping for training. And for each iteration, and the original testing set we have not yet seen. Yes, exactly. That is unseen test. Okay. So in full set we have the training part, and then from that set, one part we keep, which is our which is our validation part actually. So that part keeps varying. So the remaining part which is there, okay, this all portion, this is the set on which we are training. And in each case, obviously, because see, whenever we are saying test data, that is basically that consists of the training data as well, right? So that is not our exact test data, that is the validation data. Thank you, Mr. Shobit. That's a correct answer, correct thing to say. So we are just trying that in case this was a test data, how the model would perform. Okay, and so on. So then we see that, okay, in this case, this was the, if this was the testing data, this is how the model would perform. If this was the training data, and we train on the remaining data sets which are available. Okay, and for each iteration we go with this, and whenever all the data points are finished, then we have the iteration done. Okay, time around 15-20 minutes left. So we will, what we will do is, we can upload, we'll upload the PDF file of the this one also. Okay, the solve with instructor, as we are not having a Saturday session. Okay, this week we may have a, we may have some session in the week 4, we can combine and all. So we will upload the PDF of the solve with instructor. Okay, please go through it. It may not, won't be possible to solve all the questions or do everything now, but in case you feel some problem, okay, just let us know, we will discuss it. Okay, uh 1 minute.
Yeah, excuse me, sir.
Yeah, hi ma'am.
Yes, actually, I was going through on the web and found that about that k-fold cross
Okay, okay,
validation.
okay.
So it is written over there that we split the dataset into k groups first, and then for each group we hold out as a test dataset, and then the others are for training datasets, as your diagram was
uh
showing before, actually.
no, but actually it should be a validation data set should be there, na. uh Keyboard cross validation.
Yeah, yeah.
So
I
your
can
question
post in
is,
the chat
okay, what is
box.
the
Or
in the chat book? Okay, okay, let me
yeah,
see.
yeah, I am.
Let me check it. Where did you post? Oh my god, this shuffle the dataset randomly, split the dataset into key groups for each unique group. Take the group as a holdout or test dataset. Take the remaining groups as a training dataset. No, but then also, if you see, that is true. See, that is what I am telling. My what I am telling is this, that what Shobhit is telling is that his logic is test data is unseen. We have not seen test data. So in that case, how do we say that? Hmm, summarize the skill of the model. Huh, how do we say? So in that case, how do we say that so as test data is not seen by us, therefore how can we measure on it?
Sir,
Now, yeah,
Sir Kanika here try to represent the shuffle data set. Shuffle and shuffle with k-fold both are different strategy. Only k-fold we just split the data into
that is
training
shuffle
and
split, is it?
test. But shuffle, every time we shuffle, we take one part as a test, then we have a fresh training set. Every time we have fresh data set, test set and training set. Then we split the training into evaluation and training.
So in k-fold cross validation, we do that same, right?
No, 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 both are slightly different.
Yeah, I mean shuffle split and gatefold is different.
When you
1 minute,
do the
1 minute.
shuffle is true, the data set is up like that random state is 4201. In that case, we just maintain a particular set. Like that in shuffle, we just phrase shuffle it, take some portion for test, and another for testing. And when there is no shuffle, only K fold. So in that case, data is split it into test and training first based on your random state equal to whatever you have given random state. Then that training part is divided into K fold. You can define your folding 3, 4, 5, 6, whatever is there. Then that data will be split into training and validation. When the model is trained, the result performance will on the on-screen test data.
See, Kanika, in keyfold cross-validation, the original sample is randomly partitioned into k equal size subsamples. Of the key subsamples, single subsample is retained as the validation data, and the remaining k minus 1 are used as the training data. Cross-validation process is then repeated k times. Each of the k subsamples used exactly once as the validation data. The key results can then be averaged to produce a single estimation. Okay. The advantage is that all observations are used for both training and validation, and each observation is used for validation exactly once. So setting k equals to 2, we randomly shuffle into two datasets D0 and D1. Okay, both are equal size. Okay, someone is saying something. Okay,
Sir, I have
yeah,
shared a link.
that is the scikit-learn link. Is it? Okay, so okay.
Yeah, at
Mm,
3.1.2.1 there is they have explained
okay, let us check.
lower, little
Let
bit
us check.
more lower.
Mm, K-fold. The fold left out is used for test. Okay. Hmm. Uh, it's okay. So what you are telling is this diagram you saw, right?
Yeah, matlab I
Bolo.
understood this only when
हाँ,
we studied that K fault.
K-fold divides on the key groups of samples called folds. This is equal to the leave one out strategy of equal sizes, and the prediction function is learned using k minus 1 fold. The fold left out is used for the test. Example for two-fold cross validation is import k fold x equals to a b c d. So print, train, and test. Okay, fine. 4 samples. Okay. Here is a visualization of the behavior. No, I mean, you think one thing, Kanika. This is my testing set. Okay, the blue colors are my training set, and the maroon color or whatever this color is, this is my testing set. Okay. Now, what they are doing is they for each of the iteration. Okay, so this is CV iteration, right? So in each of the iteration, they are taking one part of the training set as the testing set. Okay. How is that possible if this is the original testing set?
So what I understood from this
Huh?
that
No, I understand. They
this
are
is the
telling me
whole
a
data
testing
set.
set. This is
Yeah,
okay.
yeah.
This is the whole data
So
set.
for
Fine.
every iteration, basically they
So
are
you're telling that.
parting that data set again and again, and then using word for like one part for testing set randomly they are choosing, right?
So you are telling some from the training set also they are taking one part as the testing set.
Yes, not from training set exactly, because they are dividing it to any k number of groups, right? So they are taking any group at randomly as a test set, and the all other remaining are as a training set.
But testing set should remain constant, right? Testing set is one particular data set only. It should not, it is not not interchangeable, right?
Then, but will be the difference like in K fold and in general cross validation we do?
No, okay. Let me get back to you. I'll post in discourse. But looks like, see, keyfold. What they are telling is yes, this is also, they mention as testing set, that I understand. So there is a shuffle, and then it is, so one model they are taking, and then the two three more types of models they are taking. Okay. Uh, so in stratified k-fold, the partitions are selected so that the mean response is approximately equal. And in repeated cross validation, what happens is that it is split into k partitions several times. And you told about k star, I put k-fold cross validation and test set. Okay, this is the time. One by one, a set is selected as a test set. The total data set is split into k sets. One by one, a set is selected as test set. Then one by one of the remaining sets is used as a validation set, and other k minus 2 sets are used as a training set. Similar to the k star I fold cross validation, the training set is used for model fitting, the validation is used for model evaluation. Finally, for the selected parameter set, the test set is used for, okay, so either evaluating the model that was trained on the test training set, or evaluating a new model that was, okay. So actually, it seems that both are possible. Okay, it seems that both are possible. Okay, so they can do a k-fold cross validation and testing set. So single k-fold cross validation is used with both a validation and the test set. So that is also possible, that a data set is split into k parts, and one by one a set is selected as the test set. Okay, so then one of the remaining sets is used as the validation, and the remaining k minus 2. So one part, so from, so like what is happening is that in that case, sorry, in that part, so from the remaining whatever is remaining, this blue color, whatever is remaining, from that part we are using something as a validation set, and we do everything, then we take, and so on. So then we shift, then we shuffle and split. Okay, that is also true. What Kanika is telling. Sets until all the possible combinations have been evaluated. Similar to the key star I fold cross validation, training set is used for model fitting, and the validation is used for evaluation of the hyperparameters. Okay, so Kanika, this thing is also there. Okay, what you are telling, and what, okay, and what Mr.
Yes, sir.
Shavit is telling, that is also true. That I mean, test set is something the model has never seen. So basically, I think what is happening is that I mean, we can take each learning. So this is leave one out. So what Shabit said, Mr. Shabit is saying, that is also true. That I mean, the testing set is never seen by the model. So both things can happen. It seems that it can happen that it is taken as the testing set. The remaining part is taken as the only the training set, and this part as the validation. What Mr. Shobit was telling, and again, what what Konika ma'am is telling, that is also true. That the sorry, the remaining part which is there, that is taken as that remaining part which is there from the k minus 2 sets, from that is the training set, and from the k minus 1 set we take one as a validation, and the other part is the testing data set. Mr. Shabit, what do you think? Okay, I'm not sure whether he is there.
In case of shuffle, if you have shuffled the data, then whatever Kanika is saying is true. When
Yes,
there
yes.
is no shuffle, then the data is split into train and test. Kanika, you do you have MLT theory portion?
Yes, Abit. Yes,
Okay,
I have
just
MLT.
go to the week one content
Hmm.
of lecture 6-7 week and page number k-fold cross validation. Sir explained it over there with pictures. I can share my screen if you
Yeah,
want.
sure, sure, sure. 1 minute. Let me. I also have not seen. Please share.
Is it?
Can no, no. 1 minute. I think I have to. Do I have to give you permission?
I think so, sir.
Um,
Or disable participant screen sharing.
I have enabled. Can you share now?
Yes, sir. That is data. If you can share, and this is the exact figure over here. This is the all the data set which contains training and test data. Training data is now folded to this is a 5-fold cross validation, and fold 1 is for validation, and the rest remaining 4-fold used for training, which is exactly explained in k-fold cross
Just hold,
validation
hold
in.
on. 1 minute. Partition the training. Key partition. So you're telling one for validation only.
Exactly, sir.
Okay.
And the same thing is represented over here. The data is first split into training and test. Then training set is divided into number of folds. And one fold is used for validation. The remaining is used for training the set. And the final evaluation is based on the test data.
So that is separate. You're telling.
Exactly, which is the unseen data.
Okay. But Kanika, what you are okay? Okay. So that I think that that's where we should draw the line. If sir has told that, then fine. But Kanika, what you told that is also true for some cases. Okay, that for some cases it is there that the shuffling is done, and we do the corresponding thing as the we do the corresponding split and fold. Okay.
Okay, sir.
Yeah, let me also just check. I mean, I have not seen the MLT slides. I have to check and look into it. Okay. Uh, Let me just go through these things once. Our I don't have actually the solve with instructor collab. I have the previous this thing. Can you see my screen? Yeah, I am trying to make it bigger. Okay, why is it not becoming bigger? Yeah. So we asked to do the following. We import California housing and we use a train test ratio, train test split. Okay, with a ratio of 70:30. So in that case, what we do, we put test size equals to 0.3. Okay, so that is the testing data set size, and we calculate we keep random static equals to 42. Okay, what did we ask else? We asked Is these two are uploaded? Can anyone please tell me? Shobita or Konika or Abhishek or anyone?
But sir, can you please repeat?
Is the week 2 solve with instructor the practice and graded solution? These two collabs or PDF of the collabs, are they uploaded in the portal?
Solve with
No, no, no,
instruction. Yes, sir.
not
It is
uploaded.
uploaded. It's
Solve with
uploaded.
No.
instructor is there, right?
Yeah, it is in week 3. They are uploaded.
Acha,
Talk with
the
instructor is there.
solve with instructor for week 3.
Actually, it contains all the weeks, whatever is there, 3, 5, everything is there.
Okay, okay. Graded and practice solution is not uploaded, is it?
No, no, sir.
Uh, okay. Yeah, yeah. Sorry, will upload it. Okay, don't worry. We'll upload it tomorrow, or tomorrow. I think it will be uploaded.
Solve with
I'll
instruction week 1, 2,
just
3, 4, and
come
6
back
is
and
uploaded.
do it. Remaining weeks, na, if you do not see that it is not uploaded, just uh, do post in discourse. And see, best thing is whoever is taking those weeks, sessions, it is better to tell them or just tag them in discourse. So either me, my name is Debajyoti, either me, Anamika, Swarnim is there. Swarnim is the best person to tag here. Okay, his ID is discourse ID is Sony. Okay, at, so if you just write at Debajyoti, at Sony, at Anamika, you have seen, I think, surely our Anandayar, or Chandan Kumar, they tag everyone a lot. Huh? So if you can do that, that will be helpful, because otherwise I also did not know that the graded solution is not uploaded yet. Okay, so I mean, nobody told me. So please let us know. I'll upload the graded solution in the discourse. Acha, so then it is great that this is not this is already there. So week 2 is there, week 3 is there, uh, 4 is not there, right? Shabit sir,
So 4 is, I think 4 is also there.
4 is there, 5
5 is
I,
not there, 6 is there.
till 6 is it? Okay,
all, yes, a 5 is not 6.
okay. So 7, 8, 9, 10, 11, 12. Those are the parts remaining. Okay. Okay, so just inform us, huh? Because I mean, nobody informed me, and I also could not check whether the graded solution is uploaded. So anyway, leave it. So let's go through this thing once. So we have the linear regression model, where we import first the linear regression, then we feed the data split earlier, and then we calculate the score. Okay. Uh, Task 3, again we imported a separate data set and did the same thing. We imported the diabetes data set, split it into 60/40. So therefore it will be then test size equals to 0.4. So whatever be the test size, the this ratio is given in the percentage, so it will be 0.4. Then we import linear regression model, we feed the data, calculate the score. Okay, so on and so forth. And then import the data regression model without intercept. You first you do with intercept, you do without intercept, and you calculate the model score with intercept, you calculate the model score without intercept, see the ratio, see the difference between that. So all those are required. And what is the some graph we have drawn? I'm not sure why we have drawn the graph. So okay, so we have drawn a fit intercept equals to true, fit intercept equals to false. If it is not there, if it is there, then we have seen what is the difference between that. Okay, and print value of intercept of the model trained on diabetes data and value of the coefficients. Okay, so again, load diabetes data set, apply with just applying the SGD regressor, huh? And so on mostly. So what is the model score? Calculating model score, train with SGD regressor. So basic thing I would say is the template. Okay, what is the template doing? What is the I mean, what is the coding template? I mean, how to write SGD regressor, uh, how to do a train test split. Okay, so kind of practice is required, huh? So how the more you practice, the more I think it will come to your hand. Okay, how do you what is the syntax of model score? What is the syntax of regressor, and so on. Okay. And so for every case, we just see the train above the above scale data set HD regressor learning rate keep as adaptive. So for every case, you can just put learning rate equals to inside a quotation mark. You can single quote. You can put adaptive. Okay, and calculate the score. Acha, so from here onwards, okay, this is not required. Okay, this from the here onwards, it is not required. Ridge regression and lasso regression, these are not required here. And I think we have done some week 8 stuff also here. So those will not be required. Lasso CV. You can start it in. This will come in the week 8, week 4, I think. Okay, ridge regression, lasso regression. Just check. Okay. So yes, and then again calculate explain variance score. Huh? So again, I will check whatever Abhishek asked, and um, so whoever whose questions I could not solve na. Okay, if you can post in the discourse, I can at least track it. I will check what k-fold cross validation Kanika and Sabit told. I'll check others also if possible. Please post in discourse. I'll try to at least attend the questions. There's a lot of question till now which I could not attend to properly, but I'll try to attend at least some of them. Please just let me know and tell that I asked to post in discourse in the live session. Okay, I'll at least try to attend or connect with sir so that I can see whatever is going on. Okay. Then whatever we have done, we import explain variance score and you calculate. It's getting a giving an error, giving an array. Okay, and max error, it is the same things as small things. So we will give. So this kind of see if we give you that we what we may do in the quiz, we may just tell that okay, the output of so what is the output of this code snippet from sklearn import max error y to this y print this max error this. Then you have to just tell that this is the value is the output is 3.0. Okay, so option 1 is 1, option 2 is 2, option 3 is 3, and option 4 is 4. Which one is correct? So option 3 is correct. Okay. So small things like that, but that will be too easy. That will be a 1 mark question. But then things like that, or if the output of this is 3, then which of the APIs we could use, or which of the functions we could use, so that the output would be 3. Okay. So I mean that is what is important. Then mean absolute error, mean squared error. Okay, as so I won't I mean push this PDF again to the portal. Okay, as you already have the data, week 2 solution I will ask them to put. Week 2 graded and practice solution I will ask them to put. Yeah. So okay, let's see. There are some more questions here. Please try to write the codes as many times as possible. I'll see the k-fold part as whatever I can do. Okay, Kanika, I'll respond to you, or I'll post the as a post I'll do. Okay, on the k-fold cross validation.
Okay, sir. Thank you so much.
Yeah. Okay, so let's stop here, and yeah, we will see you on Saturday, Friday, whoever is coming.
Okay, thank you, sir.
Yeah, sure. Any of you coming to? Acha, I think I asked also previous team. Yeah, I think some people here were coming. Na? I think Manashita was coming. Then who else? Bhupesh, is Bhupesh coming? I don't know. Okay.
No, I'm not coming. Sorry.
Okay. Okay. Great. No issue. No. I mean, there it is not mandatory. Na. It's just a diploma distribution. But there's a lot of things we are practicing. I mean, preparing for, and yeah. So that's why. I mean, we are yeah, running around. Student volunteers are doing a lot of work. Full. I mean, what footing. Okay. Okay. Thank you everyone for staying with us. Let's meet again maybe next week. We'll meet. Okay. Okay. Thank you. Let's.
Thank you, sir.